This is one of a series of videos on Nebraska's system of classifying and applying standards to its highways, roads, and streets. The videos leading up to this one covered the basics of Nebraska's minimum design standards, including the three main elements: tables, notes, and definitions. 3R work and 3R requirements were also summarized. This video uses an example county road project to demonstrate finding the applicable table and determining the standard values for each of the 13 design criteria. First, some terminology and acronyms. NBCS is the Nebraska Board of Public Roads Classifications and Standards. It may also be called the Board of Public Roads or just the Board. NDOT is the Nebraska Department of Transportation. Standards refers to the NBCS standards including design, construction, maintenance, and relaxation of standards. MDS refers to the minimum design standards, which address only the design aspect of a work or project. Standards are often termed minimum, but realize there are maximums for superelevation and grade, and ranges for cross slopes. When we say minimum, sometimes it refers to all of those. NEB-REV-STAT refers to the Nebraska Revised Statutes. NAC is the Nebraska Administrative Code. These are regulations that have the force of law. The word highway in Nebraska law also refers to roads and streets. Highway means the entire width between the boundary limits of any street, road, avenue, boulevard, or way which is publicly maintained when any part is open to the use of the public for purposes of vehicular travel. 3R is short for resurfacing, restoration, and rehabilitation. For more details, see the video dedicated to 3R. FC is functional classification. CFR is the Code of Federal Regulations. AASHTO is the acronym for the American Association of State Highway Transportation Officials. This video provides more details on the minimum design standards, specifically for county roads and municipal streets, pages 35 through 86. The state highway standards, pages 5 through 34, are not covered in this video. This video presents an example of finding the table and design criteria values that apply to a hypothetical county road project. For the example project, this screen suggests a methodical way of determining the table that applies. See steps 1 through 3, and then determining the values for each design criterion. See steps 4 through 7. The example will then compare those values to the assumed geometrics of the existing facility. The example is a road north of the city of Wilbur in Saline County. Here is a ground level view. A 20-foot traveled way is assumed with 2-foot earth shoulders. The road is assumed to be in poor condition. The scope of the project would involve reconstructing the roadway from the base up and applying 6 inches of gravel over the new base. To find the table that applies, you need to determine two things: the area type of standards that apply, urban or rural, and the national functional classification of the road. As part of the process for determining the applicable design standards table, we will check notes 2, 3, and 4. Wilbur, with a population of approximately 2,000, is a city of the second class. With the project not being in or near a city with a population of 5,000 or more, we know that the project is not in an urban area. Therefore, it is in a rural area. Before making a final determination on rural area standards or urban area standards, check Note 3 on page 47 of the standards. Note 3 allows urban area standards to be applied in rural areas that are residential and commercial in character. As you can see from the aerial view on the screen, the character of the land on both sides of this county road is rural. There is nothing residential or commercial about it. With the project being located in a rural area and nothing in Note 3 that would apply to this stretch of road, we can conclude that rural area standards apply. Find the Saline County National Functional Classification Map on NDOT's online map library. The National Functional Classification is local, because the road is not color-coded. Refer to the note below the legend. If you are unsure the road is one of the optional state functional classifications, check the State Functional Classification maps for Saline County. The road is not colored or marked, therefore it is not one of the state's optional classifications. This confirms that the road is classified as local on both systems, the national and the state. This screen is a reminder that if the National Functional Classification would happen to be other principal arterial, or if the road or street is on the National Highway System, Note 4 requires the application of state highway standards in subsection 2. Since the classification is local, that is not the case. Subsection 3 applies. On pages 35 through 86, subsection 3 is for county roads and municipal streets. Knowing that rural area standards apply and the functional classification is local, the standards table that applies to this project is found on pages 69 and 70, Table J. Be sure to review all notes that apply to the table. This video reviewed notes 3 and 4 in the context of the example. The relevance and applicability of other notes will be reviewed as we step through the example. Refer to the video on definitions and notes for a summary of all notes. So far we have done the first 3 steps and determined the table that applies to the work or project. The remainder of this video goes through steps 4 through 8 to determine design criteria values that apply to the work or project. Step 4 is to verify the work type. Is it more than maintenance work? If so, is it a 3R scope or a new and reconstructed scope? The anticipated scope of the project is to reconstruct the traveled way by removing the existing gravel and base, recompacting, and applying an estimated 6 inches of gravel over the new base. This is a scope of work more than what is defined in Minimum Maintenance Standards, pages 88 through 91. Referring to page 39 of the standards, since the base is being removed and an entire new base is being placed for the traveled way, the type of work is reconstruction, and new and reconstructed standards apply. The bridge 2.2 miles west of Wilbur would also be replaced. Page 37 of the standards indicates that this would also be considered reconstruction, and new and reconstructed standards would apply. That means the standard values for design criteria will come from the middle column of Table J. Notes 10 and 22 apply to new and reconstructed work. Note 10 would not apply to this example project since Saline County is not in the Sandhills area of Nebraska. Note 22 potentially allows some design flexibility for very low volume roads, that is, fewer than 400 vehicles per day, for the roadway and roadside adjacent to a replacement bridge or structure. Step 5 is to determine the minimum design speed. Design speed is one of the most important design criteria since several other design criteria are a function of design speed. Assume for this example that there is no posted speed limit. State Statute Chapter 60, Article 6, Section 186 requires that the maximum speed limit shall be 50 miles per hour upon any highway, road, or street that is not dustless surfaced and not part of the state highway system. Therefore, this example uses 50 miles per hour as the design speed. Be sure to review the notes associated with design speed. As a reminder, Note 8 requires the design speed to be equal to or greater than the anticipated posted speed limit. A suggestion is to lay the notes side by side with the applicable table, and you have virtually everything there in front of you. With 50 miles per hour as the design speed, it means the standard values will be in regular font, and we can ignore the italicized values. Step 6 is to determine the traffic volume for Road O. The county likely has a record of traffic volume or average daily traffic for this road. For this example, let's look at a hypothetical traffic volume as shown on this screen. Traffic volume data is represented by dots. There are no data points for Road O in this vicinity. There is a data point for the North-South County Road on the west end of the project, 55 ADT, in the year 2013. This data is about 3 years old. For the sake of not getting into a long discussion about traffic volumes, let's say it would be reasonable that traffic volume would be higher at the east end of Road O. especially just north of Wilbur, where residents on the west end of town wanting to head north on State Highway 103 may find it more convenient to get up to Road O via the north-south county road than east on Road O to its junction with Highway 103. For this example, assume the ADT is 300 vehicles per day for the half mile just north of Wilbur and 100 vehicles per day for the road west of there. Be sure to check Note 7, which is on page 48. It says that for lower volume roads, those with fewer than 750 vehicles per day, the note allows the use of the ADT for the year of anticipated completion of the work or project. It is not required to project the traffic volume ADT out to the design year for these roads and streets. The minimum requirement of Note 7 is the traffic volume for the year of the anticipated completion of the work or project. The data is 3 years old in this case. The year of anticipated completion is next year. For this example, let's assume a 1% annual growth in traffic for the 4 years. That calculation would result in traffic volumes of 312 vehicles per day for the half mile just north of Wilbur and 104 vehicles per day for the road west of there. These are the traffic volumes we will use for the purposes of design standards. For this example, let's make it simple and assume 312 vehicles per day for the entire project. There is nothing magic about the 1% growth assumption. You need to know the trends in your area. The Nebraska DOT can provide some guidance. This screen shows assistance that is available from Nebraska LTAP for portable traffic counting equipment and from the Nebraska DOT for technical guidance. This help is available only for counties, municipalities, and their consultants. Statewide traffic counts and traffic flow maps can be found on the Nebraska DOT's map library online at the link shown on the screen. Step 7 is to determine values for all other design criteria now that design speed and traffic volume are determined. The minimum lane width is 10 feet for traffic volumes fewer than 400 vehicles per day. Review Note 9 on page 49. For this example, the only thing from Note 9 that applies is the clarification that the lane width values apply only to through travel lanes. The minimum shoulder width is 4 feet for traffic volumes 50 vehicles per day through 1,499 vehicles per day. Review Note 11 on page 49. For this example, the only thing that applies is the clarification that the shoulder width values apply only to non-divided roads and streets. The minimum horizontal radius is 758 feet. The maximum super elevation is 8%. Review Note 12 on page 50. Since rural area new and reconstructed values apply, and the ADT is greater than 50 vehicles per day, nothing in Note 12 applies. The minimum crest K value is 84. The minimum sag K value is 96. Review Note 13 on page 50. Since the scope of work is new and reconstructed and the ADT is greater than 50 vehicles per day, nothing in the note applies to this project. The maximum grade is 6% for level terrain or 8% for rolling terrain. For this segment of road, assume rolling terrain and a maximum of 8% grade. For definitions of level and rolling terrain, refer to the AASHTO Green Book section 3.4.1. Review Note 14 on page 51. Since this road has an ADT fewer than 400 vehicles per day and a classification of local, short tangent lengths 500 feet or less are allowed an additional 2% grade beyond the value shown in the table. The other part of Note 14 would not apply since the ADT is greater than 50 vehicles per day. The minimum sight distance is 425 feet. We have already reviewed Notes 12 and 13 and concluded that nothing in those notes apply to this project. The minimum lane cross slope is 2% and the maximum is 6% for an unpaved road, as in this example. The last paragraph of Note 15 recommends, for unpaved roads, a lane cross slope in the middle of the range, 4% plus or minus. The minimum turf shoulder cross slope is 6% and the maximum is 8%. The minimum horizontal clear zone for a traffic volume fewer than 400 vehicles per day is the nominal shoulder width. The nominal shoulder width is defined on page 43 as the shoulder width value shown in the Design Standards table. For the example, rural area standards with a functional classification of local and an ADT of 312 vehicles per day, the shoulder width value in Table J on page 69 is 4 feet. The nominal shoulder width, therefore, is 4 feet. Review Note 16 on page 52. If any non-crash-worthy or non-breakaway obstacles other than those listed in paragraph A will be in the horizontal clear zone after the project, the county is required to justify it with an engineering study. The minimum vertical clearance is 14.5 feet. Review Note 17 on page 53. Nothing in the note applies, assuming there are no planned underpasses or overpasses, or pedestrian, bicycle, or overhead sign structures. This aerial view shows 3 structures toward the west end of the project. For this example, the steel truss bridge is assumed to be structurally deficient and in need of replacement. The other 2 structures are triple box culverts in good condition. For a bridge replacement, the minimum clear bridge width for fewer than 400 vehicles per day is 24 feet. The basis is Formula D, which is in Note 16, as the approach traveled way plus 2 feet each side. The value listed in the table is also 24 feet. If there were any structures that required 3R work, the minimum clear bridge width would be 20 feet. Note 20 applies to timber bridges, and Note 21 applies to low water stream crossings and fords. Neither note applies to this project. The minimum design structural loading capacity is HL93 for a bridge replacement. If a structure needed 3R work, the minimum design structural loading capacity is the original design loading. If that is unavailable, the minimum is HS15. Refer to Note 19. In summary, once you have found the standards table that applies to a work or project, there are several things you need to know in order to find the values for each design criteria. This screen shows the kind of information you need to know. The type of work is important to know which column of the table applies. The design speed is a key design criterion because several other design criteria are a function of design speed. Several design criteria depend on the traffic volume. Other information that may be needed are the percentage of heavy trucks, whether the road or street is paved or unpaved, or curbed or non-curbed, and whether the terrain is rolling or level. This screen summarizes the design criteria values that apply to the example project. These are all of the values determined on the screens leading up to this one. This screen compares standard new and reconstructed values to the existing road. Shoulder widths would need to be increased to the standard value of 4 feet from the assumed existing width of 2 feet. A new bridge will have a minimum clear bridge width of 24 feet compared to the existing steel truss bridge of 19.5 feet. By the way, the existing bridge does not even meet the 3R standard value of 20 feet clear bridge width. For the roadway and roadside in the vicinity of a bridge to be replaced, Note 22 may allow lower standards conditionally for 8 design criteria: lane width, shoulder width, super elevation, horizontal curve radius, K values, grade, stopping site distance, and horizontal clear zone, if there is no significant crash history related to those design criteria. And a cost-effective analysis shows that user benefits are greater than the cost of meeting new and reconstructed standards. Standard values are shown for some design criteria on this cross-section. Crash history is typically reviewed early in the development of a project, in the preliminary engineering phase, or even earlier in the planning phase. Let's take some hypothetical crash history data, as shown on this screen. More relevant details can be determined from crash reports. Details such as an embankment or trees close to the roadway that may affect the scope of work. Crash reports provide schematic representations of crashes which may be helpful to road and street designers. The Nebraska DOT's Highway Safety Office is available for guidance for counties and municipalities. The general public must contact the Nebraska DOT's Communication Division. Design standards tend to provide some level of comfort that a roadway built to minimum standard values will generally deliver an acceptable, cost-effective level of performance. However, much more goes into a good quality, well-functioning roadway than just designing to minimum design standards. In a sense, design standards consist of a few key criteria, 13 in the County Roads and Municipal Street Standards, chosen by the board, with minimum values assigned that can trigger requests for relaxation of standards. Requests are a flag that there is a situation out there that cannot meet a standard, and the board is required to review those. Standards allow some design flexibility. Some values may be on the low end of industry recommended ranges. It is the responsibility of the design professional to choose a design that is right for the particular road, that is safe for users and functions well operationally, and is cost effective. Finally, there may be a misconception to the effect that designers cannot go above and beyond board standard values, that is, be more conservative. This is not true. Realize that standard values may not be appropriate for all situations. It is sometimes appropriate to go above and beyond minimum standards. That is a design decision. It is only if a minimum board standard is not met that a relaxation of standards request must be made to the board. This is one of the series of videos on Nebraska's system of classifying and applying standards to its highways, roads, and streets. This video used an example county road project to demonstrate finding the applicable table and determining the standard values for each of the 13 design criteria.